In this video, we'll cover complex rational expressions, which are just rational expressions that within the numerator or the denominator there is sum or difference or any kind multiplication of other rational expressions. Okay, so for example, complex rational expression would be 1 over 2 plus 1 over x over 1 over 4 minus 1 over x squared. And now the question is to simplify this rational expression. Okay, so how to do that? Well, first we concentrate on the numerator separately, then on the denominator separately. Okay, so what is the common denominator between 1/2 and 1 over x? Well, 2 and x are relatively prime, so the common denominator is just going to be the product of those two factors. Okay, so if this fraction here with denominator 2 is expressed as a fraction with denominator 2x, that means that both numerator and denominator have to be multiplied by x. The denominator is already multiplied by x, so I have to multiply 1 times x, which gives me x. And by the same logic, this fraction has denominator x. If I want to express it as a fraction with denominator 2x, then I have to multiply the numerator and the denominator, both of them, by 2. So 2 times 1 is 2. Okay, so I'm going to speed up here a little bit. Similarly, the common denominator between these two is going to be 4x squared, which means that I have to multiply this 1 by x squared and this one here by 4. So here we are. We just rewrote this complex rational expression as this one right here. Now I just want to remind you about multiplication and division of fractions, and that's the easy part here. These two operations are very easy, or easier than addition and subtraction when dealing with rational expressions. So I have a rational expression a over b times c over d, and I multiply them, then the product is simply the product of the numerator divided by the product of the denominator. Okay, and if you have division, a over b divided by c over d, okay, and this form of writing, okay, most probably is the last time you see it, or at least I'm never going to use this sign in order to denote that I'm dividing a over b with c over d, but I'd rather write a over b divided by c over d. Okay, and by definition, how do we divide two fractions? I multiply the fraction in the numerator, so a over b, by the reciprocal of the fraction in the denominator. The reciprocal of c over d is d over c, and then we end up with multiplying two rational expressions, which we saw how much it is. Or somebody wants to write this faster, you can also remember this: a over b divided by c over d is equal to the product between the outer element times the outer element, so that's ad, times the inner element, divided by the inner elements, so that's b over c. Okay, so why am I saying this? Because here the outer element is x plus 2 times 4x squared. Okay, so I multiply those two. X plus 2 times 4x squared. And now again, I'm making this mistake on purpose. Please be careful. The parentheses will save your life and will help you pass this exam, Cal 1. It's everything about the parentheses. This is wrong, absolutely wrong. Okay, because I treat x plus 2 as a factor, so you have to keep it in parentheses. Okay, and I divide by the product of the inner elements 2x times x squared minus 4. Okay, and now simply let's check the common factors and simplify this. So I cancel the constants first. 4 divided by 2 is 4. Oh, sorry, it's 2. Sorry about that. X squared divided by x is just x. And then I have the expression x plus 2 in the numerator divided by x squared minus 4. Can I continue canceling? Well, yes, and that will happen only if you notice that this is difference of squares, something that we already talked about. So 2x, x plus 2 over x plus 2 times x minus 2, right? Difference of squares, a squared minus b squared is a plus b times a minus b. And then you can see that you can cancel this common factor, and the final answer is 2x over x minus 2. So this is the first example. We'll do a few more examples here. Okay, so you will very soon you will get to know this expression, right, in a more generalized form. 1 over x plus h for some constant h, right? X is the variable, h is some constant, over 1 over x divided by h. Okay, here this is equal to, I write first of all, I simplify the difference between these two quotients in the numerator. Okay, x plus h is a factor, and here x is a factor, so they're relatively prime. So the common denominator is going to be the product of those two. In order to express 1 over x plus h as a fraction with denominator x times x plus h, I have to multiply here top and bottom by x. So 1 times x is x, and by similar logic, I have to multiply 1 by this factor here, x plus h. And as you can see, I made again the same mistake on purpose, just to draw your attention that you never drop the parentheses without being extremely careful. Okay, so always keep on your parentheses and drop them in the next step when you're absolutely concentrated and know what you're doing. The denominator is just this h, which can be treated, you can observe it as a fraction. It is a fraction, h divided by 1, and that will come handy in the later steps. So just as a side note, notice how I write these fractions. Okay, so this main line here that divides the two, the numerator and the denominator, I write it right after the equal sign, in between the lines of the equal sign. Now, is this going to influence your solution? No, but it will influence the order in which you write. And of course, you want to make your teacher happy when your teacher is marking your solutions. So please keep some kind of order and neatness in your solutions, okay? So then again, I just write this as x times x plus h. I drop the parentheses here, x minus h, right? So the whole expression here is multiplied by -1. So x becomes negative x and h becomes negative h, divided by h in the bottom. So what can we cancel here? Well, so far I can just cancel x minus x, that's 0, which leaves me with negative h over x plus h over h. Now this is difference this is a ratio of two rational functions. Here you can observe this one as h divided by 1. So the outer element times the outer element is negative h times 1, which I'm not going to write, okay? And then the inner element times the inner element, so that's x times h, x plus h. And the common factor, the only one that you can cancel here, is h, so you get -1 over x times x plus h. And one more example, example 3. I'm going to speed up a little bit here. So you see I have the main line, and here I have a minus b over a minus a plus b over b over a minus b over b plus a plus b over a. So don't fall into the trap by canceling a and a, b and b, and so on and so on. Why? Because this is not expressed as a factor between as a product between two factors, but it is just a difference. So it's a minus b divided by a. Nothing can be canceled in each of these 4 rational expressions. So what do we have to do? We have to first deal with this difference. The common denominator is going to be ab, because a and b are relatively prime. In order to write a, denominator a, as a times b, I have multiplied a by b, which means I have to multiply the numerator by b, so I have a minus b times b, minus, by the similar logic, I have to multiply this numerator a plus b times a, right? Because I've written b, the denominator b, as a times b, which means I have multiplied the numerator and the denominator by a. Similarly, in the denominator I have a b, so a minus b times a plus b times b. Okay. Now this is going to be equal to ab minus b squared minus a squared minus ab over ab over a squared minus ab plus ab plus b squared over ab. So let's simplify. Let's see whether in this polynomial here I can cancel something. So ab minus ab is 0, and something similar happens here. Minus ab plus ab is 0. So we're left with negative a squared minus b squared over ab over a squared plus b squared over ab. Okay, now I have to multiply the outer element by the outer element, so that's negative a squared minus b squared times ab over a squared plus b squared over ab. And then the common factor is right here. ab divided by ab is 1. And then you notice, check whether there is something else to be cancelled. If you factor negative from here, you get negative a squared plus b squared over a squared plus b squared. And finally, you have this common factor to be cancelled, and that's equal to negative 1. Let me just check whether I made a mistake somewhere. I multiplied this one by b, so that's ab minus b squared minus a squared minus b squared minus ab. And here you have a squared minus ab plus ab plus b squared. It looks good. Okay.